Hello everyone and welcome to the last part of our video about how to study a function, and today we will finally get to the main goal, which is to be able to draw the function we've just been studying. So the last step we still need in order to draw this function is we need to find out for which values of x the function is equal to 0. So 6 plus 5x plus x squared divided by exponential 2x plus 1 is equal to 0 when 6 plus 5x plus x squared is equal to 0. Logical. So now here you just apply the delta method and you will find out that this function is equal to 0 when x is either minus 3 or x is either minus 2. So we can already put those 2 points in to our graph. We know that here the function is 0 and here the function is 0. And that is basically the only thing that we still needed in order to be able to draw this function. So let's go back to the first part of our exercise when we found out the limits and its asymptotes. We found out that there is an asymptote of y, an horizontal asymptote of y equals to 0 when x goes to plus infinity. So let's draw this into our graph. Let's write down horizontal asymptote of y equals to 0. And what does that mean? That means that when we go to plus infinity, this function will go in the direction of 0. It will tend into that direction, but it will never be exactly 0. The higher the x, the closer the function will be to 0, but it will never be 0. That's an asymptote, okay? 0 will never be reached, but it will be very close, as you will see later on when we draw the function. Okay, so that is all we needed from the first part of our exercise about the limits. Now let's go to the second part when we calculated the first derivative. When we did that, we found out a minimum point and a maximum point, so we just have to put them into the graph. So what we found out is that let me just see how to put it. Okay, like this. We found out that for minus 3 minus square root of 5 divided by 2, which is approximately minus 2.61, when x equals minus 2.61, it will equal to the minimum of the function at minus 1.19. So let's put this in. This is approximately minus 2.61, okay? And when we are at this point, the minimum will be minus 1.19, which is approximately here. This is the minimum of our function, this point, okay? Well, now we have to do the same for minus 3 plus square root of 5 divided by 2, which is approximately minus 0.38, and that is equal to 2.28 as a maximum. So minus 0.38, approximately here, like this, and this is equivalent to 2.28 as a maximum. All right, that is all we needed from the first derivative. Now, let's go to the second derivative. With the second derivative, we found out 2 inflection points. We found out the inflection point 1, which is minus 2, 0, right here. So let's write down, this is an inflection point of minus 2, 0. And we also found out an inflection point in 1 and 1.62, which is approximately here. Let's write down inflection point of 1 and 1.62. Now we will see what the inflection point is now when we draw the graph. Basically what this means is right now we can start. We found out that when, in our very first limit, when x comes from minus infinity, the limit is plus infinity, which basically means that the more we go into minus infinity, the higher the function will be. It will come from plus infinity. So we will draw like this. It goes through minus 3. until the minimum. After reaching the minimum, as we found out in our first derivative, after reaching the minimum, it will once again rise to the maximum, 2.28, and then go until 0, without ever touching 0 because of the asymptote, right? So it will once again go up. -2, 0 is an inflection point. Until now, the function was upward sloping. From this point on, it will be downward sloping. So instead of going like this, it will go like this, through the maximum, and it will be downward sloping until it reaches the second inflection point. And when it reaches the second inflection point, we found out that from downward sloping, it will once again be upward sloping. So now the function will be like this and go in the direction of 0 without ever being 0 because of the horizontal asymptote. So approximately like this. And there we go. This initial function, let me put it right here, that initially might have looked so complicated and maybe impossible to just draw by hand. Well, we just did it. We just drew this function by hand, and there you go. It was not that difficult, was it? Thanks a lot for watching the video, and see you for the next videos.